So in this problem, we've got a 3.5 kilogram brick. Just note that. And so maybe some fella is working on constructing a masonry wall for a building. The brick's 10 meters off the ground, and maybe they've forgotten to put their kick boards. So usually on a scaffolding, you have kick boards just at the edge of the platform that'll stop anything falling off the edge, but maybe they've forgotten to do that. And so he's accidentally kicked this brick off the edge with very little horizontal velocity, because we're just thinking about one-dimensional problems at the moment, and the brick's fallen to the ground. So the question was asking us, just brick mass 3.5 kilograms, dropped from a scaffold 10 meters above the ground. What's the kinetic energy and velocity of the brick when it hits the ground? Now, we could solve this using the equations of motion. And so have a go at that, just check you get the same answer. But we can also do this using the principles of work and energy. And so what we can do is we've got that little brick, it's being acted upon by gravity and it's falling. Initially, we're assuming it's got a vertical velocity of 0. So it's essentially got 0 kinetic energy to start with. It's just been gently kicked off the edge of that scaffolding. So free body diagram. So all you've got acting on the brick is gravity, and it's traveling in that direction, and it's going to fall 10 meters. So therefore, we can figure out the work that was done. So U is going to be force times change in displacement in the direction of the force. And so in this case, it's going to be mg times the height, the initial height, so let's say h naught. And that's going to be, it's a 3.5 kilogram brick, so it's going to be 3.5 times 9.81 times 10 meters. So again, I'm just being careful to use units, kilograms, meters, and meters per second, or seconds. And then I'll get my answer in joules. And so just stick that in the calculator. 98.1 times 3.5, 5 to 98.1 is 343.4 or 343.4 joules. Looks okay. So 343 joules. Now, what we can then say, we'll get to the equation of work and energy soon, but we can just say, look, this is doing positive work. It's going in the same direction as gravity, so it's doing positive work. So it's imparting energy to this brick. If we ignore air resistance, all of that energy is going to be transferred to kinetic energy of that brick. So then we can say, therefore, EK is going to be equal to the work done, which is going to be 343.4 joules. And we know that kinetic energy, you just have to learn this, half mv squared is going to be equal to 343.4 joules. What you can see is this mass is actually going to cancel out. So we've got a mass in here, we've got a mass here. So we could have kept it just as a number times the mass, and then those would have cancelled out. So it doesn't matter what mass this object has, it's always going to have the same velocity when it hits the ground. It won't have the same energy, but it'll have the same velocity when it hits the ground. And so therefore we are going to get v squared is equal to 2 times 343.4 divided by, so I'm just timesing it by, get rid of the half times by 2, divide by the mass, divided by 3.5. Therefore v is going to be equal to the square root of all that. And let's figure out what the velocity would be. 2 times 343.4 divided by 3.5, take the square root, is 14 meters per second. So we've answered both of those questions actually. So when hits ground, the velocity is going to be equal to 14 meters per second, and the kinetic energy is going to be equal to 343, it's to 3 significant figures in the answer, to joules. Now, what we could do is we could solve that using kinematics, or kinetics and kinetics, I guess, mostly kinematics. as well. So what equation would we use? Well, we're given a distance and we want the velocity at a certain distance. And so we could have solved this using that equation. So it would be the fourth equation as we usually write them. So we have v squared of s is equal to v naught squared plus 2as minus s naught. Now, what are we going to get there? So we're going to get, we want to know this, v squared s, the v naught is going to be 0, and we could do minus 2 times, so it's, the reason I put the minus is because the gravity is downwards, 9.81 times the final position is 0, the initial position was positive 10 meters, so all those negatives are going to cancel out, so v squared s is equal to minus 2 times 9.81, oh sorry, 2 times 9, just those negatives cancel out, times 10, which is 196.2. So therefore, the velocity, well, we should really put in 0, the velocity at 0 meters. Just do the same thing here. So we're talking about the velocity when it hits the ground is the square root of that. It's roughly 14. Okay, and so we could have got the velocity from that equation. Then we'd have to stick that into the equation for kinetic energy, and we'd have got the same answer. It would end up being 3.4 joules. Okay, so again, we're seeing that using this idea of energy as an alternative way of figuring out the velocity of an object at a given position. So it's just an alternative way, or we could have used the equations of motions that we'd learned previously.